I'm creating a video to assist you with the homework problem that I'm going to assign. This is to give you sort of an introduction to SolidWorks simulation, the FEA side of it. And this is an extension of what we did in homework 2, where we created this gear pair and we made a drawing out of it. So hopefully you have that assembly still, that you didn't throw it away. So you can, now we can adapt it. So what I'm going to do is give you some ideas on how to set this up so that it'll be fairly easy. The first thing we want to do is make sure that we correct anything we had wrong in homework 2 in terms of the way that the gears are attached to each other. So I've gotten rid of some of the mates that I had previously. You can do this, what I'm about to do. There's a couple varieties that you can do, but we really only want to have two gear pair in contact with each other. We want to make sure that they are contacting each other. So one method that we can do is to add a mate, and I think this is what I did previously. So in assembly, I'm going to go to mates, and I'm going to click on tangent ahead of time, and I'm going to click this face and then click that face. And these should be now brought in contact with each other, right? Even though they don't look like they're in contact with each other. Another method that I did is I took these curves and I added a point in the sketch that you're seeing laid on top of this, and I made sure that this curve was touching that in contact with, coincident with that point, and that this curve right here was coincident with that point. But I think we're going to be okay doing it this way right here. So you could do it either way, but just don't have another pair where they're close to touching each other. Like for instance, if we had like that right there, maybe where they're close, I think it'll be okay right here. So we don't want to go that close either, right there, where we don't want that pair in contact. I'm pointing with my finger, which doesn't make any sense. All right, so that's the setup that we want to make sure that we have. And some people didn't have that set up that way. Which was part of the instructions, but that's okay. That's homework 2. We want to fix that. Now we want to go into SolidWorks simulation. You might not have that activated, or it might not be available on your version, so you might need to transfer these files onto one of the computers in the lab to be able to do this. So let me know if you don't. So we have these add-ins right here. I'm going down to the gear up here and go to add-ins. And we want to come down and see SolidWorks simulation. I already have it checked right there, and you can also see you can make it on startup, so it starts up every time. So if you have that, this tab will be available to you, SolidWorks simulation, and we can go to study, and there's a bunch of different choices. Some of these might not be shown on every student's version, but the one we really care about is the static right there. And actually, tell you the truth, the 2D simulation, simplification, might be a better thing to use. Might make more sense in terms of computer power. But let's just stick with the static right there. We'll go with the 3D and see if it works. So you'll see we have another tab here at the bottom. It says static 1. And we have a tree. And this tree, will just follow it logically downwards. And we start with parts. You'll see that we have two solid models right there inside the parts. We're going to right click on there and apply material to all, right? So if you wanted to do individually, you could just go to individual ones and apply materials up here, but we'll apply materials on top of both of the parts. And this useful dialog box comes up, and they'll show you the material properties for a bunch of things, but we don't really care about what these material properties don't really change a ton, at least not the ones that we care about, which is the elastic modulus and the shear and the Poisson's ratio. Those are the ones we really care about. And if you want to change the units, you can, just to see what the numbers are, but it doesn't matter. The computer knows what system of units that you're working in, and it doesn't really care. So I'm just going to pick the alloy steel. Why not? But you can see there's a bunch of others, but you could explore for yourself and see. All you need to do is hit the apply button, and you should be done. And you can see next to the components here, it tells you that you've picked a material. So if you've assigned the material properties, so we're done with this, we go down to connections. The default connection is to globally bond something. That means we've glued these together. But what we really want to do is make sure that these two are separate objects, but they can't pass through each other. So we want to edit this, and we hit contact instead of bonded. What this does, just simply, is it makes these little elements, or will make little elements that you can't see, called gap elements, and they act like sort of a switch. They exist if, well, for instance, if this thing starts crushing, right, it's going to get flatter and flatter. Initially, when there's a curvature, it's really theoretically only touching at one point, which is actually a line across the face. But as we know with contact stress, the bodies in contact will begin to deform and become flatter, and so the amount of space that's in contact with each other will increase, right? Well, for that to happen, there needs to be like a little switch that turns on, and so these contact thing does that for you. In other codes, we might have to actually place those or do like a little bit of more work on top of them. But that's neither here nor there for today. We're just going to go ahead and use the automatic feature here of contact. So we've taken care, and you can see that it even looks like a little a cam and a roller, right? So these are typical things that have like contact with each other. Now we go to fixtures. So we have to make a couple choices. I'm going to go with I'll just go with the fixed geometry one right here. And we're going to fix this shaft, right? So this one's going to be fixed. And well, let's just accept that. And now I'm going to go and do the fixtures again. And I'll pick the fixed one, but I'm going to go advanced instead. So I'm going to go advanced. And then I'm going to go cylindrical faces. And I'm going to pick this face right here. Now, what I want this to be able to do, I want to be able to rotate so I can apply a torque to this, but I do not want to allow it to shift. Well, as you'll see right down here, we don't want it to shift back and forth in the Z direction. And we don't want it to move, well, we don't want it to move in the X or Y direction either. Right, so we want it, but we do want it to be allowed to turn about the z-axis. So what we will do is we will fix that way, right there. So that's not going to allow it to go up and down, left and right, whatever. And then we're also going to stop it from moving in the z. But we are not constraining that rotational degree of freedom right there. Boom. So now we take care of fixtures. Now we go to external loads, and I should have calculated ahead of time what load I want. So I'm just going to use an example load, and I'm right-clicking and then going to a torque. So I'm going to place a torque onto this face right there. So that's going to be like the shaft is applying this. And then I also need to have a reference, and we could use an axis if we had one in the center. But I'm just going to go ahead. It'll accept a round face, right? So that because it's round, it'll know now which direction you're talking about. And you can kind of see the preliminary arrow, or it would be nice if you could see. I'm not sure if those arrows, I think those arrows do represent the rotation. So you're going to see, I just hovering over this, you can see that the default is counterclockwise, which is good because this gear tooth needs to be pushing against that gear tooth, right? So the pinion needs to be pushing against the gear. We'll change the units, and I'm going to put 100 inch-pounds in there. I'm not sure if that's a value that's going to give me any kind of like meaningful stress, but we'll go ahead and leave it in there. But you should calculate what your load is going to be, and in inch-pounds. For the power limiting power that you have for your gears. And then if you need to reverse the direction, by all means, reverse the direction, but you want it to be going in a direction that will, of course, push on the gear instead of trying to pull the gear. And so we'll accept that. And now what we have is a model that's almost ready to go. The next thing we want to do is mesh, right? You notice we're going down this list and we're going to mesh. And I'm going to create a mesh. I'm just going to create a crude mesh and see what happens. It may or may not work. All right, so I'm just hitting this, and this is just a rough mesh. And you can see that that's not a lot of elements right there. We really would want a lot more elements, especially right here in the contact zone and where we're going to have a high stress, probably on both pieces right there, right? So we want to be able to kind of learn something from this. So I'm not sure I want to accept this mesh for this. It might actually crash because, as I mentioned, those gap elements need to be in there, and they need nodes in order, and the nodes on both sides need to be near each other. So because I don't think it's going to mesh, I'm not, going to run. I think it's going to crash. Well, let me see. I'll just go ahead. I don't want to waste too much time. It's going to set this thing up, and if you're, oh, there it is. Okay, so it gave us a solution. I'm not sure that solution is going to be very good. I'm going to set up my stress while we're here. I'm going to set up my results. Okay, so it gives these results, but I'm very particular in how I want to see the results. So please follow these guidelines as I bring them up. The default is von Mises stress. That's great, but the units are newtons per meter squared, which is a Pascal, right? We would prefer to have KSI because we're dealing with US units. So that's one thing. It also does a rainbow contour plot where it goes a smooth transition from one color to another. I don't like that at all. So, and then it has these random numbers. I don't like that at all. So I want you to change edit the definition. So this actually, the edit definition, chart options, and settings. You could click any of these and they will come up with the same thing. You'll see there's definition, chart options, and settings. So under definition, we could change it to different kinds of stress right here, but von Mises is the default. We can change it to KSI. That's good. And then we can make the deformed shape of the thing change. It doesn't really affect us for this. So a lot of times I just make it a single. I can just make it user defined because we're not really dealing with deflection. Under chart options, you can show the maximum and the minimum right there. By the way, it hasn't updated what it's showing yet. I'm going to go ahead and make some guesses for the range. And I'm not going to put the show in the maximum and minimum. It's not really what we're interested in. But I do want to take the minimum value and make it, and that's the maximum value. We don't know what that is yet. I'm going to set it at 100. I don't know. No, probably 10 KSI. It's probably not going to be very high. And then I'm going to make the minimum 0. Right. And while I'm here, go down here and change this to floating. And get rid of the keep it to maybe, I'm going to do 1 decimal place right now, but we would like to get rid of the decimal places. In fact, I'm going to leave it as 1 decimal place. Here's one where I really would like you to change. Go to color options, and I got it at 10. That's good. You'll notice that, well, 10 and here is 10, so I'm going to get an even increment. And so I want you to plan that out to get an even increment. And then the last thing to do is go to discrete right here. And you might consider putting the mesh. I think we could put the mesh on top there, right? So those are the 3 things to do: the definition, chart options, and settings. And we'll see what the result is. Okay, so we got scientific notation for some reason, but you do see that we have this good increment right here. So we want to come back and change this, edit the definition. I'm going to come back down to have floating. I'm going to have 0 decimal places. And I note that I have I'm not really using my scale very well. So I'm going to have 5. Oh, now that I've done that, I'm sorry, I do definitely need to have a thing. Maybe I'll even have 2 right there, like that. Okay. So let's see what that comes out to be. There you go. You can see 0.5, 1, 1.5, 2, 2.5. You can see. So we're getting a better appreciation for this stress, but now we need to maybe ramp this up a little bit. Before I go further, well, I could have done this later. I am gonna actually make this, let's make it something like 50 right there. Okay, so 50 and make this 0 right there. Okay, so 50. So all you see is blue because we're all below here, but we're going to update this torque and let's make it 1,000. I don't know if that's going to be good or bad, whatever, in terms of the values. And then lastly, I want to go to mesh, and I'm going to add in apply mesh control, and I'm going to grab that face and that face, and I'm just going to make it, swing it all the way to fine. You can keep making it finer by reducing that increment right there. We'll make that fine. I'm going to do another mesh control. I'm going to apply mesh control, and I'm going to go to places that really matter. Right there, right there, right there, and right there. And once again, I am going to just take it and make it fine. I could even make it smaller if I want to. And now I'm going to go mesh here. I'll hit right click mesh. I can create mesh. I can actually do mesh and run, but I like to do it, see it. I'm going to leave the coarse mesh onto the outside, and let's see what our meshes look like. Hopefully it'll go. All right, so we've improved our mesh. We could take it down even more, but this is maybe better. We should probably do a little bit more refinement, but let's see if we can make it run. If it takes a long time, you can hit this more button and watch on this convergence plot right here, and it'll give you something to do while you're waiting for the thing to solve. But there you go. So it's solved. All right, cool. We might come over to these controls, and can we hit the? We can hide the controls because this making little purple things. But you can see now some more of the effects of this stress placed on here. Maybe we'll go to here and edit our chart settings again and make it to 25 instead. Let's see, is that going to give me, I needed more decimal places in there. So let me go back and edit my definition and go to 1 decimal place. It'd be good if we had the background to this. Can we set the background? I think I can. But you can barely see it when these are out over here. But you can see what the values are. So this right here is a pretty decent observation of what's going on with the stress in a gear. You see it didn't take me very long to do. But, I can mess around with what I chose for my controls right here, okay? Because the number of elements around here are probably not enough to really give us a good sense. Because you can see right across one element, there's a large amount of stress change, at least according to the scale that we're using right there. So this doesn't have a fillet radius to it, so that's one of the reasons. This is a very sharp corner, so that's a stress concentration, unlike what we'll have. And this right here, these are representing the contact stresses that are taking place in the between the two gears. And so what we could do is change this right here, and I don't want to go too much further, but we could try to change these. If you go too far, it'll start crashing on you, just to let you know. But we will go ahead and try to see if we can get some more elements. See, not great right there, but it's better. And then you can run it and see. So it's doing all this stiffness elements. It's getting it's created the matrices, the stiffness matrix, and now it's doing the iteration. Now it's doing the contact constraints, right? So there's those contact elements. You see, it's solving contact constraints, and so it's really kind of doing an iterative process where it's the pieces are deforming, and so it has to recreate a stiffness matrix each time, and now it has solved. So you can see now it's got sort of an interesting looking thing. You have to remember that this is a tool and this is not the answer to what the stresses are, but we're getting a better sense of how the stresses are distributed, right? And remember, stress is the distribution of internal loads, so this is what we've collected. Now, displaying this or providing this as a thing that for the at least for the assignment, here's what I would like you to do. You can go to View and Screen Capture and just go Image Capture like that, and then place it into a Word document. Boom. And maybe you can do image capture again, like this right here. What's good with this is that we have already put the oh, I'm sorry, I didn't show this. All right, so I pasted this in. So I opened up a Word document and I pasted it in. It was on my other monitor. And with just it was already in the queue, right? Already in the clipboard, and you could just save this, and then you could write out your observations. You might also want to take another screen capture of this. Another screen capture and pull it in and put it in right in there, right? So now you have like the big picture and it has the scale. Actually, you could read the scale pretty well right there. And maybe in here, write in what I've asked you in terms of your observations about the stress, about the gear stress. And that will be sufficient for getting an introduction to using SolidWorks simulation and applying it to the gear. So I'll do a demonstration in class of this as well. So that was our video that I've created for assignment. This is like homework 5, I think, that's coming up, where I ask you to use AGMA tools to calculate stress. And but here I want you to do them for use FEA for that. So we're done.